So it's a great pleasure to be introducing our next speaker, who's going to be giving the Burland lecture. So this is the key lecture of TC306. We're very fortunate to have Marina, I have to look at the name, Pantazidou, to make sure I get it right, to give this lecture. So Marina has been a key figure in TC306 for many years now, has been the chair, and I'm sure most of you are familiar with her. She's very keen on pedagogy and developing things which are useful for our community. So I'm sure we're going to hear some of that today. So over to you, Marina.
I will talk about the title in a while. I would like to start with some favorite people here, so, you know, to cheer for me wherever they are. First, our hosts, Farima Masrouri and Adel Abdallah, for giving the third John Burland Lecture a home. The late Waldemar Hashish for creating the John Burland Lecture. John Burland, my professor at Imperial College. Here you see him preparing a demonstration for his talk in the last TC306 conference that did not have a Burland lecture. The late Andreas Anagnostopoulos, my professor and then colleague at NTUA, the support of TC306, yay! And in particular, Michele Calvello and Margarita Pino Lopez, the inspiring GEE2025 authors. I had the privilege of reading many papers, and that's a great thing to be in the editorial team. So Katia Bicaglio, Gretchen Bonhoff, Michele Calvello again, Wolfgang Felin, Ansgar Kirsch, and Christina Vulpe. And I'm sorry, I'm only saying the names, the first authors here. Thalia Travasaru for advice and encouragement. And last but not least, Christos Stratakos, Vasilis Boukouvalas, and Ilias Kevrekidis at NABA Lab in Athens. They gave you an amazing in-house tutorial on compaction. So let's get going here. No? Okay. Here. So I wrote the paper and prepared the lecture for two possible audiences. The first one, to the left, it's the real title, the actual title of the presentation. It's about changing attitudes, organization, and scale in engineering education. And the title to the right is an alternative title for those of you who would like some geotechnical engineering meat. Okay, so this is the hamburger patty. It's producing geotechnical engineering teaching materials for soil compaction. And I use that meat patty, soil compaction, as a vehicle to talk about the proposed and implemented changes. So these are the objectives of the presentation. The first objective is to advocate these changes that ultimately, I hope that they will add the role of the teacher as a go-between for people and ideas, and the role of committees like TC306 as a knowledge broker. Now, this objective really goes hand in hand with content. So a dual objective is to draw attention to the content of teaching and to teaching materials. And in order to do that, in order to both draw attention and to advocate the changes, I will provide examples of the advocated changes with teaching materials, some figures, not something small, for soil compaction. There is one final objective, is to enlist peer reviewers for the developed teaching materials. So this is what I would like to achieve. This is the outline of the presentation. The real outline, I meant what I wanted to do to the left, the actual outline to the right. Number one, geotechnical engineering instructors, we know now that they need better educational material. Number two, educational material need peer review. Number three, educational material need I will show that they will benefit too, I hope, to be developed within the framework of pedagogical content knowledge. And this is a new concept, perhaps for some of you, and I will spend some time explaining it. I will talk about the development of some small-scale open educational material for soil compaction within the proposed framework of pedagogical content knowledge. And very briefly, number 5, I will give an example of combined small-scale educational material and crowdsourcing. And hopefully, all these things together will lead us to see an enriched role of the teacher as a go-between and of TC306 as a knowledge broker. There is an engineering education in the title, and because education is too many different things to different people, to focus this presentation, I will distinguish between content. So an example would be soil compaction or geotechnical engineering. This is something similar to knowledge that Jennifer Case talked about in the morning. So content versus method. An example of method would be problem-based learning that is used in medicine, in engineering, and in other fields. So we are focusing in this presentation on content. So from education, we went to content, and from content, I would like us to go to educational materials or course materials that are specifically designed to be used in instruction or can be used in instruction with minimal adaptation. So not taking just anything and use it in our class. Things that have been explicitly developed to be used in instruction. Included are textbooks, papers written for this purpose, online material, software. I use this definition from these good Greek colleagues. Now, further, I will categorize educational materials into teaching materials for the teacher and learning materials for the student. Sometimes these are common. A textbook supposedly is for both, but there is no reason to have these two together. These are different populations, they have different needs, and I'm going to talk about the educational materials, the subset, the teaching materials for instructors. Which are the customers of TC306? The customers of TC306 are instructors, mainly. So, do we have the educational materials we want? We asked this question with Michele Calvello several years ago. It was published last year, and I think it only has one reference and one citation, and it could be my citation, actually. So nobody knows the answer to this question, I trust. So it's a very interesting question, since nobody knows the answer. So that's the answer. It's about half and half. So 52% of materials used are below personal standards, okay? I'm not saying they're bad, I'm not saying this, I'm saying what the respondents told us, that they're not happy, they're not super happy with what they have. So there is room for improvement, and perhaps we can help them in TC306. So that was number one. Do we have the educational materials we want? Half of us, the answer is no. We asked more things, but it's not for this presentation. Now, number two, the question of peer review. This is an open-ended question. It's not like the previous one. I ask something and I know the answer. So, given that educational material is the only artifact teachers leave behind, we don't know what's happening with their students. We really don't know. Jennifer talked about assessment. We are groping with assessment. We are not very confident about what our students learn. But our teaching materials is what we leave behind. Our videos is what we leave behind. So given that, and given that most university teachers are steeped in the tradition of research, really, how come that our only artifacts are not peer-reviewed? They can be, it's an open question. I don't have the answer. I have one proposed answer, and this is a hypothesis that perhaps because we have student evaluations, we say, okay, we have this quality assessment tool, we have student evaluations. If my hypothesis is the explanation, then we have to ask further, what are the student evaluations good for? What do they measure? And to find this answer, we have to go to the literature of education. And I have some references here at the bottom. I have all the references at the end of the presentation. Well, the literature says clearly, unequivocally, that students' self-assessment is not correlated with the respondents' performance. If you ask a student what helped you learn better, we should take the answer with a pinch of salt, and the literature explains this. I'm not saying that we shouldn't get student evaluations. I'm not saying this at all. It's a very valuable customer satisfaction report, both for education and administrations. So my argument is that we need them both, but for both peer review and student evaluations. But for teaching material quality, we better ask our peers. So that was number 2. We're moving to number 3. And so far, we discussed indirectly about content through educational materials to motivate changes of how we perceive facts. Facts about whether we have the educational materials we want, facts about what we can use student evaluations for. Now we will go closer to the heart of content and view it from a teaching perspective to motivate changes about how we approach knowledge. So we'll get a little slowly here. So let's view content from a teaching perspective, and look at the phrase at the top left, knowing content to teach it, okay? So knowing content, not just knowing content to teach it. So if you understand this phrase, then you understand pedagogical content knowledge. That new concept, okay, it's 40 years old now. It's knowledge of the ways of representing and formulating the subject that make it comprehensible to others. This is a definition by Schulman, the guy who created, perceived and wrote about this, this concept. Now, let's view X, for example, compaction, from a teaching perspective. So knowing X to teach it is the pedagogical knowledge of X. So whereas the pedagogical content knowledge is that concept I mentioned introduced by Schulman, pedagogical knowledge of X, it's the application of the concept. And I made this figure here to distinguish between domain-specific and domain general knowledge for teaching X. So number 1, content-related knowledge for teaching X versus pedagogical knowledge for teaching. Let's see if I can do that. No, I cannot do it. Okay, that's okay. So it's really content-related knowledge for teaching X we are talking about. We see that it includes 3 things. Of course, we should know X, knowledge of X. So the new thing is the pedagogical knowledge of X we will talk more about. And the third is curricular knowledge of X, which is what teaching materials are out there. I should mention that Schulman developed this concept having in mind more primary and secondary education. So as you know, at these lower levels of education, there is a lot of discussions about curricular materials and what teachers have in their hands what do they have to teach. So for us is a little different. There's less discussion on tertiary education, and perhaps this is now time to change. So Schulman also gave us the ingredients of pedagogical content knowledge. The quotes are his expressions: the most powerful analogies, illustrations, examples, explanations, and demonstrations. Demonstration, we saw the photograph of Professor Burland, but pedagogical content knowledge is not only demonstrations, these things also as well, analogies, illustrations, examples, explanation. So it is all about explaining for understanding. He also included an understanding of what makes the learning of specific topics easy or difficult. So this includes students' misconceptions, things that students might find difficult to understand, and because for us they're very familiar, perhaps we don't perceive that. So pedagogical content knowledge also includes a knowledge of what might stand in the way of understanding. So pedagogical knowledge of X, we spent some time on that, and educational material. So I make the hypothesis here that we can find fragments of pedagogical knowledge of X, our own area, geotechnical engineering now, not something else. For example, illustrations and explanations in the textbooks of the domain. And I will give examples of soil compaction. Now, nobody has thought of that before, I don't know. But even if nobody has thought of that before, there is an explanation, because as I mentioned, the concept was developed primarily for primary and secondary education. These are what the departments of education cater to, primary and secondary education. So we'll see. And further, I will make a claim that keeping in mind these ingredients of pedagogical content knowledge helps in the production of educational materials. Now, this one, I think it is self-evident that if we aim at cumulative progress, we have to know what other people have done before we do our own thing. So for the next several slides, this is the biggest part of the presentation. I will give examples of pedagogical knowledge of soil compaction that I have extracted from textbooks, and in this process I have also extracted some open questions. So that was, I didn't expect that. And I will give an example of developing educational material for soil compaction. As I mentioned, just a few figures, a small scale effort is here within that framework of pedagogical content knowledge. And I will try to argue that there are some internal rewards for the developer in doing that. So where did I extract this knowledge from? From these books. So I surveyed 9 introductory textbooks, 1 specialty textbook, physical and geotechnical properties of soil, so it's more focused. That's why I called it a specialty textbook, and a specialty book in Greek specifically on soil compactions of embankments. So you see the names here, they are listed chronologically by the year of the first edition of the book. So I read Terzaki and Peck, the second edition in 1967, but the first book was 1948. So these are quite well-known textbooks. We will hear more about textbooks in a while from Michele Calvello. So these are the textbooks. And here I will make also another hypothesis question mark. I don't think I could have done the same thing if I had those books in an electronic format. I took the pictures to show you that I have those books. Okay, I lift them, I looked through them. I could open them easily. I didn't scroll up and down. For whatever is worth, I'm making this comment. Perhaps researchers in the future will have something to say about that. So that was my day in the lab. That was my day at the NAMA lab, where I had this tutorial on soil compaction. What is soil compaction, Jenny? We are delighted to have you here. It's a form of soil improvement. We take the soil and we make it better. And the main idea is we run some standard compaction tests in the laboratory, and these standard compaction tests guide the field compaction with rollers. A very simple idea. So the pictures you see here is a standard test, a hand-driven test in the left, a mechanized test in the middle, and you see a compacted soil in the soil mold, the standard mold, how you get it out of the machine. You remove the color, you shave off the top, and the bottom right is what you measure. Now, you run 5 or 6 of these tests. Why 5 or 6? Because sequentially you add more and more water, and what you do, you plot the compaction curve, which is the relationship between the amount of water and soil density. So at the end, we get a graph. At this point, we can slow down again. It's hot, it's nice to slow down. And think about this. I think it's a defining fact for soil mechanics. I don't know how you feel about it. Soil mechanics relies on tailored testing procedures designed to yield targeted results. I think we more or less agree with this. Now, is that more than other civil engineering specialties? A question mark for the future. The consequence of that is that we depend on the graphical representation on the results. And given that consequence, the pedagogical decision is which graph best represents soil compaction for teaching. That's our decision. What is at stake when we make this decision? That our choice becomes the archetype. That one graph that we will choose, we either select from a textbook or make our own, will shape students' concept of soil compaction. That's a heavy responsibility. So my personal resolution is the best I can do as a teacher is to choose the simplest graph that reflects my concept of soil compaction. And in doing so, you get the bonus of getting the challenge to clarify this understanding for yourself, for myself, as I was doing it. So really, that was a bonus. And before I show you some graphs, I should also here pay my respects to all textbook writers in this room. I don't know how many of you are here, but if one single graph requires so much thinking, then I cannot imagine what a whole textbook requires. So I'll show you here two archetypal compaction graphs. This is from classic textbooks. So these are great names here, so you cannot use the names to choose. To the left, you have the two compaction curves that show the effect of mechanical energy. Okay, the lower compaction curve has a lower amount of energy, higher energy, more mechanical energy, a denser soil. So the left one is Terzaki and Peck. The right one is Taylor. And I will ask you to think, not to tell me, to think, and perhaps tell me later which one you would choose in your teaching. What I'm doing here is I'm showing you the effect of if you have only one textbook, you see a compaction curve, and you say, oh, that's very nice. Okay, I'll put this in my PowerPoint. Now, if you have 2 books, or if you have 9 books like I have, you start picking differences, and you start thinking, which one would I select for I'm not asking. So this is the curve that I finally made. I took a graph from Friendlut and Arharjo, and I modified it to have the most desirable characteristics I decided I wanted. I wanted dry unit weight. I didn't want density. I wanted at least 2 lines of constant degree of saturation, so that we know where we are at the optimum point. As I studied this, I understood the importance of saturation, which is not highlighted enough in compaction. Number 3, I wanted these lines of constant saturation that are not measured, they're just drawn, to be drawn with a known specific gravity. And there is one undesirable characteristic that this graph has. It is from an unknown soil. I was shocked as I was reviewing all these textbooks to find out that we have, most of our graphs are generic. We don't say what soil, just the soil, as if it didn't matter. That was shocking. So I go back because I want to show you that, because I think that saturation is very important, I would never change the graph to the left because it has a compaction curve that really touches the zero or voids line. And I don't know, or I didn't know, I think I know now what kind of soil would that be. But I believe that it couldn't be a soil with a significant fine-grained portion, which is the main reason we are interested in compaction, more or less. Okay, so what did I extract for textbooks? This is an example. The graph by Taylor includes 3 measures for density: dry, unit weight, porosity, and void ratio. We put too much emphasis on void ratio in soil mechanics. Porosity is a much more useful quantity for other civil engineering disciplines that deal with soil, and somehow students don't hear about it. I think this is a pity. I show here a graph from Powery that adds specific volume as an alternative measure of soil density. And if you plot a specific volume as a function of water content, then the lines of constant saturation become straight lines. So you have this nice fan. And you see how saturation moves as the soil becomes denser and how little it changes after the optimum point. So this is a sampling. There is more in the paper. I would like to spend a little more time on the unanswered questions that I found by studying the textbooks. The most basic question I had, and the reason that I had to make sure I went to the lab and see how compaction is done and discuss with people who actually do these things, is that I couldn't get a straight answer. Is compaction basics, as it appears in textbooks, applicable to all soils? My area of expertise is environmental geotechnics. I knew about compaction for landfill liners, fine-grained material. That's all I knew. It makes eminent sense for fine-grained material, but for coarse-grained soils, it didn't make sense. And only the specialty textbook said unequivocally, a curve is usually not drawn to obtain maximum density. And the Greek book further explains that it makes no sense in the field. You actually put as much water as you can as you compact a coarse-grained soil. And this is actually what my colleagues confirmed to me in the lab that I visited. So I felt much better. I felt I learned something. The other question was what I mentioned: what saturation values to expect at, past the optimum point. I believe these 2 questions are related. My tentative answer is somewhere between 85–90%, something like that, for soils with sizable fine-grained content. So there is more on this, but the talk is not on compaction. So now moving on and adding to the pedagogical knowledge of soil compaction, as I mentioned, I developed some small-scale materials, targeted teaching materials, though I think this is important. When we do something, we also say what we want to achieve, because if we say what we want to achieve and how we do it is not very successful, but our target is useful, then someone else may improve on what we did. So target number 1, help students explore alternative ways to describe how dense soil is. I will show you an example of this. Target number 2, promote degree of saturation as a key soil parameter. Target number 3, stress the variety of compaction curves. Target number 4, guide students to think about the role of soil particles. This is more general than compaction. The role of soil particles in defining the soil's personality. Perhaps we don't do enough of that. I'll give you an example. Now, for helping students think in alternative ways, instead of having 3 measures on a single axis like Taylor had, I have 3 graphs. I think 3 graphs is easier for students to see that whether I plot dry unit weight or porosity or void ratio, I get the same curve. I get the same curve, but be careful, dry unit weight, I want it large, big, and it increases upwards, whereas the other 2, they decrease downwards. So you have 2 versions of these figures. in case somebody with a visual literacy background tells us this is more useful with the students. And in thinking about that, I think that this would be even more useful. The curve I have in the lower right, this is how we actually do it with our hands. We just draw to the axis and we put the arrows. So I will have a third version of this one. So I'm showing you here a tiny thing. We heard that people are doing, in their labs, they're doing compaction. So perhaps, some figures like that could accompany a lab session on compaction. The second figure that I made, and I like this, I like it. I took two compaction curves from four different soils, and I plotted them on the same graph. In the textbooks stress the importance of energy on how the curve looks like. Two of them, they stress the effect of the soil type, but I saw no graph combining the two, and this is what this does. So you see, for example, that the plastic clay, the yellow curve, which is not great material, but if we compact it a lot, then this plastic clay will become better than a sandy clay. So the top yellow line is better than the dotted green line. And you see how you don't have a uniform deterioration of dry unit weight decreasing with increasing percentage of fines, because these are the usual graphs you see in textbooks. You see these flippings between the kinds of soils. So I thought that this finding, this concept, I don't know how to call it, we can describe it with the analogy that soil particles is to soil what yarn is to textile. So we know that with the same yarn, we can make many different textiles, but we cannot make any textile we want. So in soil mechanics, we do stress the importance of the soil particles on the behavior of the soil, but we don't stress enough the kinds of soils we can get with the same soil particles. And perhaps compaction is our opportunity to do that. So this is a summary of, in the paper, in the appendix at the end, it lists the contents of the supplement. The arrows are the new figures I created. In case someone finds it useful, and some other materials, for example, the list of the textbooks, I reviewed some excerpts for the textbooks, some comments, and some other exploratory things I did playing with ChatGPT, but without doing really any research on compaction. David, how much time do I have? Okay, so then I can talk about why did I choose compaction. I hope that somebody, would ask me that question. Michele Calvello has a paper. He reviewed I don't know how many textbooks, and he, can I say a few things? It's an introduction. It's a preview, okay? It's an ad. So about compaction, he said that some textbooks cover it, some textbooks do not. Huh. And I thought, this is very interesting. So it's optional, which means that if you don't cover it, you don't lose anything. Perhaps, someone can arrive at this conclusion. So, but you look at, so I ask myself, is there a future for soil compaction? And if you judge by its research past, look at the names that have researched soil compaction. William Lamb, Harry Seed, Mike Duncan. I mean, all these people have done research in compaction. Have we solved all the problems in compaction? That's why we don't hear much about it. At least I don't hear much about it. Anyway, I don't know about research. As I said, I just, played a little bit around. But about education that I thought a lot, I thought that compacted soil is a model perhaps a model for a soil in depth, is a model for an over-consolidated soil, a soil that has high lateral stresses. That's what compaction does, increases the lateral stresses. I found that in William and Lamb, because it has the compaction chapter in William and Lamb is the last one. So the students or the readers know about lateral stresses, so they have this very useful comment there. Another opportunity would be, we talked about, Jorge Zorben talked about building with soil. That's how I call it. Jorge said it in a more sophisticated way. Okay, so building with soil, perhaps, this is the easy way to introduce soils because we have control both of the soil we pick to build and what we do with it. So perhaps instead of starting from building on soil with all its difficulties, perhaps building with soil would be an easy introduction. Finally, maybe, and we will hear more about that, maybe compaction will have a comeback through teaching unsaturated soil mechanics, and we're going to hear more about this from Bicalio and Vulpen Beckett, so I don't need to say anything. So more or less, I'm wrapping up here what I did for soil compaction. I would like to talk a little about my experience in doing so. This is number 5 in the outline. So for an individual, small is very doable. So writing a textbook is a huge undertaking, but just pick one topic and just go through several textbooks. This is doable. So this is the opportunity that we have by reducing the scale. The title said reducing the changing attitudes, scale, organization. So this is the scale in the title. Smaller than a textbook, smaller than a paper. I showed you just a few figures. So this is really very doable. Also, Jennifer Case, she showed the transition between scholarly teaching and all the way to research in engineering education. We can be somewhere in between this, this spectrum, and we can also be outside. Okay, we can also only contribute some small things. So reducing the scale offers the luxury of focus, and again, personally connecting to the collective pedagogical knowledge offers this privilege of serving as go-between for Terzaki and Taylor and Peck and all these great minds. So now, small is also manageable for a technical committee. We are volunteers, so this reduced scale of contribution is compatible with volunteer work. It facilitates peer review. So I hope that a few of you will review my figures. And also the reduced scale of contribution, when we combine it with crowdsourcing, allows us to both have significant output and permits reaching out. And this is the point where TC306 is now. We can ask from people outside TC306 to do things for us, to meet some of the teaching needs we have, as long as we ask something small. So I think we are about to do that. We haven't done this yet. In doing so, by reaching out, TC306 becomes from a knowledge hub to knowledge broker. And I think this is a very, very nice future to look forward to. So I will give you one example of work of TC306. This is, we call this small-scale contributions geotechnical engineering education posts. This is one post that reviews some geoengineering pop quizzes by Timothy Stark. Since I have the time, I can tell you that this is a story of a knowledge hub. So the president of the Greek Geotechnical Society told me, hey, Timothy Stark has these neat quizzes. And I said, okay, recommend a few ones to see. He recommended some. Indeed, they were good. Michele wrote an article, short article on that. Several members of the committee picked their favorite quizzes and commented on them. So now This is not the most recent. I think now there are 73 or something like that. But it's very difficult for someone to review 73. But you can go and just look at number 30 that is reviewed by TC306 member Jenny Kalioglu. She liked this one, and she explains why she liked it. So this is an example of small scale with crowdsourcing, how we combine it in TC306. So, I said at the beginning that I put together this lecture to advocate some changes. So it's, the paper is partly opinion paper, is partly a case study, is partly education, but because I focused on changes, I will close my summary and conclusions. I put them, I imagine if I had 5 buttons to push, and I would push 5 buttons and 5 changes will take place. So the first button, the first button I will push, I think that we should make it known that we do not have the educational materials we want. I said only one citation of our paper by myself. Please start referencing that paper. You can say, like Pantazidou and Calvello, we studied this, or unlike Pantazidou and Calvello, we studied this. So everybody can reference this paper. People need to know that we don't have the materials we want, because if you want to apply for funding to create some materials, they will say, oh, come on, the internet has so much, you don't need the money. No, we have to make it known, okay? So we have to motivate this development of the teaching materials that we want. The second button is promoting a culture of peer exchanges in education. I showed you some evidence from research data that show the limited scope of student evaluations. Here, what do we want? We want peer selection, we want peer review of teaching materials to become mainstream. The third button would be the one I would choose if I was granted only one wish, and that would be to recognize that teaching in a specific field requires its own body of knowledge, distinct from evidence-based teaching practices and distinct from subject matter expertise. I gave you references from the literature. What is the result here? We want to develop our teaching materials within this framework, and by developing the teaching materials within this framework, we add to the framework, we add to the pedagogical understanding of our discipline. Perhaps this is a personal preference here. Teachers, when they act as go-betweens for people and ideas that promote the value of derivative work, perhaps you need to change your values and think more about derivative work. And the result here is we need to provide some motivation in the absence of external reward. And the last button I would push, I would like TC306 and similar groups, teaching and learning centers, perhaps departments of engineering education, to act as knowledge brokers for creating the content, the teaching materials we don't have in order to address teaching needs. So these are the references that I have used, and I would like to leave you with this photograph. What I did, I presented you this little stone in this pattern here, the one that is highlighted in red. This is what I talked about with soil compaction, and the rest perhaps is our future. This pattern we can all create together. And I thank you very much for your attention and future input. Thank you.
Okay, so we have a few minutes for questions. Marina's keen to have 5 minutes at least, so please, who wishes to add to the conversation, suggest how we're going to solve all the problems.
Thank you, Marina. Very inspiring on a number of things. One question, I like very much the idea of peer review in teaching material. How? In the sense that we do the same in research, But when we publish in the journal, we get a reward about that because the publications in the journal are counting for our promotion. When we are reviewing for free, but for journal papers, we get a reward because this is counting for promotion. Where to publish the teaching material or where to make it available and who is reviewing that and what the reward is, because there is no money in general for teaching. So we have money for research, but teaching is not funded, not yet, maybe in the future.
That's why I try to promote internal rewards. As to the organization, this is the job of TC306, of some, of some group of people. And peer review, again, it's for something small. And we are not talking about peer reviewing, correcting some error or because we are all self-taught, we don't know whether our preferences are just pet preferences or insights. So opening to more people, it gives us some balance.
My reflection out loud, is there room to publish in geotechnical journals, maybe not the top research ones, but there might be room to publish teaching material, formally peer-reviewed, that is counting as teaching material, in some of the journals that are somewhere in between that might be interested in that.
Again, publishing in journal is not the only model to think of. This is quite involved and it's not small scale. I talked about small scale, just making things available. There are plans, and I didn't have time to talk about that. We have already have a place in the SSMG website, and we have publicized some small-scale teaching materials for environmental geotechnics, and the plan is to do this for soil mechanics, but I don't really want to talk about that because we haven't started doing this. This is the possible future, but it answers your question.
Okay, we had some more in the middle.
If I can add to the discussion, in the States, there are several places where you can publish your curriculum and have it be peer-reviewed. There are websites that make those teaching materials, your PowerPoints, your homework assignments available to other instructors. They are primarily at this point for, K through 12, the primary, secondary education, but it's a venue where you can do that. And some professional organizations also have special issues around teaching tools and things like that where you can publish.
And actually, we have a paper in this conference, but I want to leave this paper for a surprise.
Back to the graphs. So you showed two classic compaction curves, that they have their merit in the sense that they are historical papers. And there is a merit for that. I was curious on whether you found in the more modern, potentially teaching-oriented textbooks, I was surprised that you didn't find any that would say, yes, this fits what I want. So do you need to create material, or you need to look for the material that was created and trying to find if it already fits?
I don't even like the one I have because it's for an unknown soil. So I hope that through the peer review, some compaction curves will materialize that will be for a known soil, ideally with a known distribution curve. But in the paper, I discuss how the textbooks are becoming more and more conceptual and cartoon-like, no real data, and I think that's a problem.
Okay, do we have anyone else? One more question? No? So just before we stop, I rather like the idea of compaction. I don't know about anyone else in the audience. I think there are more people here, but I think you'll find quite a lot of current research going on into compaction. So, it's a history, but I think we'll be revising some of that as we go on. Okay, which brings me to we need to thank, again, Marina for her very interesting talk, and I have a little gift to provide her with.